I'm particularly happy to have him here today. And before an official introduction, I will just say a few words on why I thought it was great to invite you to come over. I think we first met very briefly online for an ICCC workshop back in 2024, Colors of AI, that I helped co-organize, and in that event is when I got to know Terence and his work, and I was particularly impressed by how productive, particularly as you describe, almost hacky attitude to artistic research and research-led artistic practice can be, and the results it can yield, particularly for allowing us and bringing us with new materials for thinking what these technologies are doing to us, to our artistic practices, to our curatorial strategies, to culture at large, to society at large. It may sound a bit pretentious from my side to say this, but actually I do think that particularly the type of approach that Terence represents very well in his own practice is very productive and very necessary. Certain closeness to the technology, experimentation, and certain playfulness with it. It is fascinating, it's scary, and we cannot stop looking, right? So this is what it is. So without much, I will just say a few words. Dr. Terence Broad is an artist and researcher working in London. He's senior lecturer at the University of Arts London Creative Computing Institute and holds a PhD from Goldsmiths, University of London. His research-led practice takes a hacking approach to working with generative neural networks that treats them as artistic materials. He has built frameworks that allow for the expressive manipulation of generative neural networks and developed data-free approaches to training and configuring neural networks that open new possibilities beyond the conventional imitation-based learning. His art and research have been presented internationally at several conferences such as SIGGRAPH, Leonardo Newitz, and museums such as Whitney Museum of American Art, Ars Electronica, Whitechapel Gallery, etc. In 2019, he won the grand prize at the ICCD Computer Vision Art Gallery, and his work is also in the City of Geneva's Contemporary Art Collection. So thank you, Terence, for being here, and the floor is yours. Yeah. Look forward.
Thanks, Dario, for the introduction, and I just wanted to say thanks for organising this event and inviting me to speak, as well as to Maria. I really enjoyed all the talks yesterday and very much looking forward to all of the talks today. So, this talk's titled AI as Artistic Material, and, Dario gave a good introduction. I recently completed my PhD. I did a PhD in computer science at Goldsmiths, but I've also had an artistic practice working with generative AI for about the last 10 years. And generally when we think about AI, when people talk about AI, there's these kind of two modes that people talk about the way that AI is used as a tool in creativity. So AI is either this tool for creativity in the kind of language of HCI and AI. You would call this a creativity support tool, or the framing is that AI is a kind of autonomous creative agent that's making decisions, independently of human input. And then within that sort of dichotomy, we have this sort of spectrum of human-AI co-creation, where there is a sort of sharing of creative agency responsibility between the human and an AI agent. And this is the sort of very standard framing that comes up a lot in HCI, also computational creativity research. And when I was writing my PhD, sort of in the last few years, writing it up, I was really struggling to sort of situate my work within this framing. I didn't really kind of feel like what I was doing was co-creation or using AI as creativity support, or using it as a kind of an agent that would autonomously be making creative decisions. And so I ended up coming up with this sort of alternative framing of AI being used as an artistic material, and one where artists sort of play with the technology, interact with it, but try and break it through processes of hacking. And this was a framing that really tries to sort of center agency back with the human, but not not as a tool, but as a material to play with and experiment with. So, when we talk about AI, there's a huge amount of things that underpin it. So we have these vast data sets, often scraped from the internet, that are used to train these generative AI models. We then use highly nonlinear, multi-dimensional optimization algorithms that are being used to sort of train and optimize and configure the weight parameters of these models, and then through that process of training, we end up with a series of weights, a series of learned parameters of a neural network that in some way kind of represent the data or have been sort of configured through this optimization process and through these massive data sets to then give us all of these sort of this black box of kind of parameters that we don't really fully understand what it's doing. And underlying that is then huge amounts of computational resources, increasingly vast sort of data sets, data centers, of tens of thousands, if not hundreds of thousands of these really highly specialized machines that underpin all of this. And we combine all of these things together, and we end up with this kind of thing. So this is a video generated with Google VO3, which is Google's video generation model, presumably trained on pretty much all of the data on YouTube. And we're able now with these generative AI tools to produce synthetic media that is so realistic, so lifelike that when we look at this, it's very easy to sort of forget all of this very complex chain of computational contingencies and infrastructures that go into it. So what I'm going to talk about in my talk today is autistic interventions in AI, using AI, generative AI in particular, where these interventions have been made sort of through a kind of hacking approach a lot of the time. And these interventions kind of elucidate something about the way that the AI works, the way that the AI functions, sort of shows us the kind of materiality of the AI, computational materiality. And so I'm going to talk about 3 projects from each of these categories. First, AI and inference. So after we've trained the model, we would perform a forward pass through the model and generate some media. So this is the first category of projects are just using kind of the standard approach where we train a model to imitate data and then do something not normal with the way that model works. And then after that, I'll talk about 3 projects where interventions are made in the training process of AI. And then finally, I'll talk about projects where interventions are made after the training process, so changes to the model or to the way that the model should function. And I'm not just going to talk about my own work, so I'll be talking about a lot of my own work, but also be talking about projects by other artists that fit this kind of framework and this narrative. So to begin with, I'll talk about autistic interventions in inference. So the first project I'm going to talk about is this project Introspections by Philip Schmidt. So in this project, Philip Schmidt took image translation models. So this was done in 2019, sort of using what's now quite an old approach. So these models would take an image of one input, output something else. So this example is a model that would be photo to sketch, take a photo, give you kind of the outlines. And what he did is he fed an empty image, so kind of just an array of kind of white or black images into this model, got the output, and then recursively fed it back through, and through this process visualized the sort of internal hallucinations, the state of the model. So, just to sort of give you the technical diagram, feeding in this kind of empty array, something that's out of the distribution, so to speak, of what this model's been trained on, what it's not expecting, and then recursively feeding it through to sort of elucidate its state. And he did this with photocolorization models, sketch models, and then ESRGAN, which I believe is an image denoising model. The next project I'm going to talk about is called Writing Noise into Noise by Eric Salvaggio. Eric's an artist who works with AI, is also a great writer, and he just uses commercial tools, so he uses things like Midjourney, DALL-E, and then interrogates them in interesting ways, again, through this hacking approach. So, without sort of going too much into technical details, sort of current state of the art in image generation and increasingly video generation and music, audio, is this process called denoising diffusion model. So you start off with kind of a random image, random noise, called a Gaussian noise, and then you use a model very similar to what we saw previously, and this will iteratively kind of try and take noise out of the image and introduce structure. And what Eric did was he prompted this model with the prompt Gaussian noise. So, it starts with Gaussian noise, which is sort of a mathematical description of randomness, and then gives this to this denoising diffusion model, and then the model is trying to get to the point that it's already started from, which is Gaussian noise, but it can't do it. It's always trying to add structure, it's always trying to add sort of patterns to this. And this is a big series of works that he's done, and I think these images are really quite stunning, but they really sort of show that the model is always trying to add structure to what it's seeing, adding these patterns, and can't really follow the sort of what the prompt should be. I'm now going to talk about a project that I did 10 years ago. So when I was doing a master's at the time, a research master's in creative computing, and this was just as kind of early generative AI models were coming out, and I did this project where I was trying to do video prediction. I ended up training a model called an autoencoder on all of the frames from the film Blade Runner. And originally when I did this, I was sort of interested in this being a kind of a creative tool. Maybe we'll train it on Blade Runner, and then we'll see what happens when we put other videos through this as a sort of mapping from one to the other. But one of the things... Yeah. Okay. But one of the things that I did in my experiments was actually it was trained on all the frames of the film Blade Runner, and then I then decided to recreate the film, so re-sequence every frame through the film, back through this model, and it gave this imperfect reconstruction. Somewhat dream... Oh. Sorry about this. Okay, right. It gave this imperfect reconstruction, ended up sort of becoming sort of quite a sort of a dreamlike state, and what was really happening is that when the motion in the film was still, it would the model would in effect kind of see these sort of visual images a lot more, but then when there's lots of motion, it would see them a lot less. So it created this kind of imperfect reconstruction, and for anyone that's seen the film Blade Runner, the whole film is about kind of these artificial humans called replicants who have artificial human memories implanted into them. So it was the obvious film for me at the time to do this. And this kind of reconstruction of the film, which was just sort of, done as a sort of as an experiment, really became a thing that people became interested in. So again, taking all the frames from the film, training it on that, and then reconstructing this. And this sort of, at the time, was a bit of went against one of the sort of big sacred tenets of machine learning research, which was you test it, you don't test on your training data, I had lots of people kind of commenting online saying I was just overfitting to the data set, and this was just a very bad compression algorithm. Obviously now kind of a lot of these machine learning models are regularly being evaluated on the data that they're trained on, and people don't really seem to care about this as much. But at the time, this was went against the sort of standard tenets of this. This, I was very lucky, this work was exhibited all over the world. The first exhibition it was in, notably, was at the Whitney Museum of American Art in the exhibition Dreamland's Immersive Cinema and Art, 1905 to 2016. And I think the thing that sort of got a lot of attention in this project, I know certainly the curators at the Whitney had sort of came about my work because when I'd originally done the project, I'd uploaded this whole reconstruction to Vimeo. Within about a week, it was taken down by Warner Brothers under a copyright takedown act notice, and then ended up being covered in an article in Vox that ended up going viral. And so the project got a lot of attention because of these kind of legal issues. It wasn't really the thing that I was, trying to sort of provoke, but this ended up becoming quite instructive in my sort of subsequent practice, because even though Warner Brothers rescinded the takedown notice, initially they've subsequently reissued it. I was just, every time I had an exhibition, I was just like really dreading, getting a cease and desist notice from Warner Brothers, and it was a lot of stress for a large number of years. And so going forwards with my artistic practice, I really didn't want to do this again. I wanted to use generative AI in my practice, but I didn't want to be using the standard mode of generative AI, where you're training on someone else's data, someone else's creative work, and then kind of deriving value from that and extracting value from that. So this moves me on to the next section, artistic interventions in training. And the first project that I did after that Blade Runner one was this project Unstable Equilibrium, where I spent months and months trying to figure out how to train a generative AI model without any data at all. So it took a lot of experimentation, but in the end, the way that I came up with this was that I had these two image generation models that were trying to copy each other, trying to imitate each other, which didn't do anything, which initially didn't do very much remarkable, but then I also got these models to compete with each other to produce more colours than the other network, and was very surprised kind of by the results. This was an approach where there was no data, there was no external sort of formula for what this should look like, and actually this kind of competing for these colours was just a very crude thing. It was very surprising that we ended up with such sort of kind of tasteful things. So I'll not go too much into the details of this, but this was based on the GAN framework called Generative Adversarial Networks, where this was the sort of standard way that people trained image generation models back in 2018, 2019. And so you have this generator trying to imitate a data set, and you've got this other network, the discriminator, that's trying to tell them apart. And so the way that I went about this was just I swapped out the training data with another generator. So these generators were just sort of starting from random initialization and trying to imitate each other. I did a whole series of experiments in this work, and so each experiment was a different kind of configuration of the code. I was really sort of like really just sort of trying to experiment and not worry too much about the underlying maths behind it, but just freely experiment with the code. And so I had these 6 experiments, all with different kind of variations on the code, slightly different objective functions. This was a sort of series of works that came out of that. And this work has been sort of exhibited in media arts festivals, so FAL Festival in Sao Paulo. It's going to be exhibited in Switzerland in September. But I also have exhibited kind of physical prints of these works, and also more recently did a sort of digital release with a gallery called Solos on the art platform Verse. And for me, it's kind of the artworks were the models themselves that came out of these experiments. So sometimes this work is shown as an hour-long video, sometimes it's prints, sometimes it's much shorter videos, but it's really, the artwork was the model itself, and that can kind of be reused a lot, and I'm starting to reuse that in other projects. The project that sort of followed this was, I was thinking about this kind of training without data, but what people did at the time was take models that had been trained and sort of try and fine-tune them on other data sets. And so I had this idea of, okay, what if we fine-tune it not on data, but with another AI model? So again, going back to the SCAN framework, this generator network is always trying to have its outputs being predicted as real by the discriminator as kind of real data. And I was kind of interested in, okay, well, this discriminator is also trying to work out what's fake. It's trying to give predictions of what a fake image might be and what would happen if we kind of optimize towards that. So started with this model, this NVIDIA style GAN model, and then sort of took that initial starting point and then optimized towards this sort of artificial representation of what might be fake, and this kind of ended up being kind of a reinforcing cycle, a sort of feedback loop. So very quickly, you know, the more that the model got better at producing fake images, the more that the other network thought was fake, and these kind of loss functions, objective functions just exploded in the space of about 10 minutes, a very quick process. But what was sort of interesting to me was that, you know, I remember showing these pictures to people, and they were just horrified by them. And for a while I thought I'd done something kind of bad. And then I sort of, revisiting this, I was like, oh, there's something interesting here. And really this kind of process is kind of maps on very closely to this idea of the uncanny valley, which comes from robotics. So I wrote a paper called Amplifying the Uncanny, and then had this series of artworks, you know, where I sort of picked the kind of peak uncanny checkpoint from this process to make these images. I'll go quite quickly, but more recently, when I was writing up my PhD, I kind of reran these experiments, and without getting too much into the weeds, I was trying to get rid of that kind of exponential feedback loop. So I use this mathematical, I took the log of the loss, which kind of removes that exponent, but accidentally ended up trying to optimize this network towards something that didn't exist because the log of a negative number is undefined. So it's kind of, you have these gaps in this training thing. So it was kind of being optimized towards something that it could never quite get to. And this process went on and on forever. So you didn't kind of get that kind of quick collapse of the model. And you could do this. This was a process, I ran it for like 3 days at home, and it would just go on and on and on. So more recently, I sort of have started making new works in this unstable equilibrium series, using that technique, but starting from a random network, from a random initialization. And in these artworks, you can kind of see that process of training, and this will kind of go on indefinitely, forever. But again, sort of surprising that sort of such a crude kind of objective ends up producing these kinds of images. So I'm going to sort of have to speed up a bit. The next project I'm going to talk about is a project called Strange Fruit by Malsom. So again, this was sort of in 2020. People were using NVIDIA-style GAN trained on faces, and then fine-tuning it on other data sets. It's just a much more efficient way of kind of customizing your own model. And Malsom was training it on kind of religious iconography, this kind of thing, and he ended up doing something that was really innovative. He started to feed kind of the outputs from the training back into the data set of the model in this sort of kind of recursive way. And using this sort of process of feeding it on its own outputs, was able to really kind of push what it was being generated into something completely different, novel, new. But he was posting about this on Twitter, posted these quite cryptic messages, and I was like, started to talk to him and understand more about what he's doing. But he kind of identified very early on that, you know, when these models are trained on their own data set, on these synthetic outputs, they tend to kind of collapse. You get this thing called mode collapse, where everything kind of breaks and it just sort of produces a single output. And he kind of intentionally would induce this, and then he would kind of pick the checkpoint just before this state of collapse, where he thought the most interesting things were happening, which was kind of the process that I also did in the previous project I was talking about with the uncanny faces. And so then he was able to sort of take that checkpoint, that stage of the model, and then, you know, produce lots of works with this under this strange fruit. Called Strange Fruit. And I think what's kind of interesting about this was that a few years later, then this suddenly became a very hot topic in research. Lots of people started doing formal studies on this, and I wasn't surprised when I was reading this, because I was like, oh yeah, well, you know, this artist did this years ago, like, obviously, but it wasn't kind of obvious to anyone else. And you know, this became a huge kind of area of concern, because obviously now these AI models are being trained on all the data scraped from the internet, but increasingly the data on the internet is from AI models. So this is kind of was in the Financial Times and the New York Times and like business press, because they were so concerned about this impeding kind of development of AI. So the final thing I'm going to talk about is artistic interventions after training. So once we've trained a model, can we make changes to the weights and other parts of the kind of flow of computations in the model to sort of push these networks in different ways. So the first project I'm going to talk about is Neural Glitch by Mario Klingerman. This was done in 2018, so kind of very early on. And what Mario was doing was deliberately taking the weights of the models and kind of trying to corrupt them. So, replacing them with zeros, replacing them with random numbers, kind of swapping these weights around, and through this kind of making the artifacts that kind of existed in GANs, they don't really exist anymore with these diffusion models, making them more visible, making them more apparent. And so he did sort of a number of experiments with this. So this is kind of the same permutations he's made to the weights of the model using different latents, different kind of inputs for the generation, and you get this kind of consistency of effect. Or you can put the same latent in the same starting point, but then make different permutations to those weights and get kind of a variety of different outputs. And then I think this example is the one that sort of really elucidates this. The best is here he's kind of gradually erasing the weights of the model. So from the starting point on the left is what the original model would be generating, and then increasingly kind of corrupting and destroying the model over time. I'm now going to talk about this project by Justin Pinkney called Real Ukiyo-e. Justin was kind of a researcher working at MATLAB, I think, at the time, and but was kind of doing a lot of this like creative AI hacking work on the side, and he did this project where he started blending the weights of networks. So kind of, again, this is sort of style GAN trained on faces, and then a model that he'd sort of fine-tuned on ukiyo-e, which is sort of Japanese painting style, and then was able to kind of fuse these two models together and to produce something quite new. So if we have the weights of these two models, you can kind of average them uniformly across all of the weights of the model. You experiment with kind of swapping layers at different stages of the model from one to the other, or you can kind of like be a bit more sort of deliberate about this and kind of do this in a kind of graded interpolation way. So, and so this is kind of on the left is the original Stargan model trained on faces. The right is his kind of fine-tuned, customized model on ukiyo-e, and then depending on like the order in which you're sort of combining these models, you can get quite different results. Sort of like the sort of spatial characteristics of ukiyo-e with sort of real photorealistic kind of features, or the other way around. And then the one on the left is kind of this kind of more deliberate graded interpolation approach. And again, he did this project in 2020. There's now a whole area of research called model fusion, where people try and kind of blend models together, usually LLMs, try and eliminate biases, try and improve kind of these models. And it was sort of something that was done first by creative practitioners before now it's become this big area of research. And finally, I'm going to talk about some more work that I did in my PhD, and this was where I tried to kind of hack into the model and try and take the sort of black box of the model apart and start to make interventions into sort of the representations inside the model. So this came up with this framework called network bending, where basically you take a model apart and then insert filters that could be deterministically controlled by an artist or creative person, a bit like a guitar effects pedal or a Photoshop filter, but building that inside these kind of neural network frameworks and to allow people more kind of creative and expressive control. And again, all of this research happened at sort of a particular time where StyleGAN was the main tool that everyone was using. So this was work that I did where, took the GAN apart, and then inside the GAN, these representations, you have these kind of, they're called activation maps. They look like tiny little images, and you can really sort of, if you spend a lot of time looking at them, you can really identify what they're doing just by where bits are lighting up. And so this example is, we've got all of these sort of activations lighting up kind of around where the eyes would be, you know. So, a lot of people have built on this work. NVIDIA incorporated it into their StyleGAN 3 model, which was a sort of subsequent foundation model for image generation that they came up with. And lots of other people have built interfaces around this for music generation and visual image generation. And more recently, there's a lot of research now in large language models, trying to take them apart, trying to understand what they're doing. And there's this technique called feature steering, where basically you sort of take the model apart, try and figure out if you can identify kind of representations in a large language model, and then you can then start to manipulate them. So turn them off or dial them up. And the most famous example of this is Golden Gate Claude by Anthropic, mechanistic interpretability research team. And here they identified this sort of one feature in the network that represents the Golden Gate Bridge. And so if you dial this up to 100, then every time you speak to Claude, ask it a question, it'll always talk about the Golden Gate Bridge, just sort of like this pathological obsession. And so this feature steering is basically network banding by a different name. And I'm probably kind of running out of time, but you know, just to finish, a lot of the research I was doing sort of falls in this technical umbrella called active divergence, where we're not trying to imitate data, we're trying to do other things with generative AI, trying to push it or actively diverge from the original data distribution towards something else. And this was first coined by Burns and Colton in 2020, and I ended up writing a survey of these approaches that I presented at ICCC 5 years ago. And I'm not going to go through all of these, a lot of them I've already talked about, but I think what's interesting is that most of these approaches were sort of developed first by creative practitioners. And actually, there are now a number of methods in AI alignment, like feature steering, like model fusion, like machine learning, where alignment is really trying to move AI models away from what they've been trained on towards human values and whatever that means. And there's a lot of overlap between these kind of creative approaches and what these large tech companies are doing to kind of steer and guide these models and put guardrails around them. And I think this is a really interesting sort of area of kind of research. And I think from a kind of, we're talking about kind of generative curation. I think these approaches of sort of trying to manipulate and shift the biases of these models after training is going to be a really important step forward. And I think a lot of my research going forwards is going to be in trying to open up these tools for kind of creative research, and really look at how these things can be used in a sort of artistically productive way. So that was a lot of information. I appreciate. Thank you everyone for listening.
Thank you.
Yeah.